Here we have the matrix spiral design. This is made from a carbon composite where we have layers of carbon fibre and glass fibre. The reason for that is that we have areas that need to be stronger and can be made more rigid, and then we have areas that can be a little bit more flexible. The design features of the matrix spiral is that we have a lower profile anterior shell, and you can see the strut coming down round the side of the leg. The idea being that the strut is anterior to the actual malleoli, so that we definitely clear the anatomy for comfort. The anterior shell can help absorb plantar flexion and dorsiflexion, so it always picks up through swing phase. It can be for a low to medium activity patient, and it's good for shock absorption. If we have a look at the actual foot plate design here, the foot plate you can see has a contour to it. The reason for that is inside most footwear we have a heel pitch where the heel can be 10 millimetres higher than the ball of the foot, and then we have a toe spring which is approximately 10 to 15 degrees. So building it into the off-the-shelf brace means that when it goes inside the footwear it then sits much more fluent against it. So we have a Velcro strap at the top of the calf. What's great about that is it's much easier for a patient to take on and off. Along with that is the foam liner. The foam liner is stuck in with Velcro also. We automatically supply a second one of these. Because it's making contact with the patient's skin, they can then remove it, have it cleaned while another one's put in. With the matrix spiral, we can add on things like insoles, whether they're prefabricated or they're made custom. If you have a patient, for example, that pronates mildly or supinates, you can have a prescribed insole that can be placed on top. Now, with the foot plate only being a couple of millimetres, they tend to fit well inside footwear. Let's have a look at the alignment of the lower extremity in the device. What we're looking at here is the anterior tilt of the tibia. This should be approximately at 10 degrees inclination forward to mimic normal biomechanics in gait. If we don't have 10 degrees of inclination forward, what we could look to do is provide, for example, a heel raise, whether inside the footwear under or over the matrix device, or we can consider using a rocker sole adaptation on the footwear. Not only we could do heel raise, but we could make it a point loading rocker to help influence biomechanics in a positive manner. If a patient has true gastrocnemius contracture, where they don't have plus 5 degrees dorsiflexion, this is where we consider using those heel wedges or adaptations to then create the position that we can see here of the anterior tilt forwards. Let's have a look at the matrix spiral being fitted onto a patient. You start with this posterior to the patient, turning it anti-clockwise to don it appropriately. The first thing we do is select the size of the foot plate's length. This must be appropriate to be slightly longer than the actual patient's foot. With the device comes a flat insole with double-sided tape. Remove the backing and then this can be fixed onto the foot plate. By altering the position of the insole in relation to the foot plate, the position of the lateral strut can be moved relative to the lateral malleolus. When selecting footwear, it's important to look for a slight rocker sole, where the heel pitch is 10 millimetres higher than the sole thickness at the ball of the foot. Also looking for a toe spring of approximately 10 degrees, which is consistent with a standard shoe. One option with footwear is if they have an insole that comes as part of the shoe, this can be used instead of the insole provided with the device. Then we put the device into the patient's footwear and don the entire lot as one piece to make it easier for the patient. The strap that we have at the calf is posterior. You'd make sure you do this up with enough tension to hold the device against the patient's leg. You then want to fasten the footwear, whether that's Velcro or laces, with decent tension, and then the patient is ready to walk in the device.